If you encounter messy patterns and uneven deformation while working, then the weld is definitely substandard. To avoid this problem, you must first understand the cause. There are 3 key points. First, when welding stainless steel, everyone has a concern that high current cannot be used. This is incorrect. The current depends on the thickness of the plate. For example, for 5-6 millimeter thick plates, what current filler covering capacity is appropriate? 90% of people would think 120, 130, or 110, but actually, a lower current will... This causes your patterns to become messy. Sometimes we might think, and if I use a smaller current, it'll be easier to control, so why is the pattern still messy? And the biggest difference between high-speed stainless steel and high carbon. Steel is the state of the molten pool. One is very dense. The other is very sparse. If you apply water to high-speed stainless steel and then use a smaller current to manipulate it, the water will look sparse and uneven. It won't be round. It will be elliptical. It won't be able to spread out the typical patterns. So, if you move it left and right, you'll find that the patterns on the stainless steel are very messy. This is a problem with the current. The second is the movement of your welding torch. When we're practicing hand-cranking welding, we crank it using our wrists. Many beginners, especially when they first start learning, will clench their teeth and grip the handle with tremendous force, afraid it will slip. But the more force you use, the more slippery it becomes. There's an old saying, something from martial arts training, about using softness to overcome hardness, you understand? The more you can't hold it, the more you need to relax. Once you relax, you'll find your hand becomes lighter, and with a lighter hand, there's less force, making it easier to control. So, the first point is about the hand cranking motion. The prerequisite is relaxation when you crank the handle. When using this grip, never use this numb big knifing grip. If you grip it like that, you'll find it very difficult to lift, especially when you reach the upper part where you can't lift it up. Your whole body will follow and you won't be able to lift it up. So this method is wrong. The proper way to hold a gun, especially for dry steel, is to use the "Mare don't shoot me" grip. How do you hold it? Extend your little finger like a pocket gun. However, this method is only applicable to the lower part of the pipe. After you reach the upper half of the pipe, when you're at about the 10 o'clock position on the slope, as you walk, take your little finger out of the gun. Why do you need to weld your little finger to the upper half of the pipe? At a 45-degree angle, you need to keep your little finger. To avoid you not being able to raise the gun, if you put your little finger here, you'll find that when you try to raise it, your little finger is stuck, so you can't raise it with force. If you move your little finger to the opposite side, towards the outside of the gun, and use your little finger to exert force upwards, you'll see that the gun can be raised. So, this avoids the problem of not being able to raise the gun. Why? Because if the lower half of the circle is not messy, the upper half of the circle is messy. The gun isn't raised and the angle isn't right. This is the second and last step, which is our key point. What we need to sell is white steel. Why? As we just talked about, the biggest characteristic of white steel is that it sticks. You need to use a large current. After using a large current, you'll find that the temperature is too high. So, at such a high temperature, it's flying! Can't you just do it like that? We need to use a large current and a fast pulse to spread the molten iron widely, so the temperature is lower, thus solving the problem of high temperature. So the last step is the pulse part. You need to understand one thing first, right? The shape of the pulse part is a circle and the pulse wave is elliptical. If you let the capacitance swing left and right to maintain a circular shape, it means the temperature is too high. At this time, you must stop and lower the temperature or reduce the current. After you lower the current or the temperature, you will find that the capacitance becomes elliptical. At this time, you can control the size of your pulse. Many people have a misconception that the needle tip is pointing upwards. They all think that the sweat should be blocked at the pulse point. The sweat doesn't need to be blocked. Where to block it? Use your needle tip to block it. Your 5 needle tips move from the left to the right and down. Then you need to sell it upwards. Sell it to the position of the clip on the top of the shoe. I weld it to both sides and let it sell. After moving it from this side, the next step is to move it diagonally upwards to the groove position. I'll show you a high-definition recording. Friends who have watched this far, please like and follow.